there's going to be a time during the course of this semester when you are going to work on a problem and your answer is going to be wrong. Sometimes it's not so easy to tell that that answer that you got was right or wrong. If you get the answer and maybe it's way, way, way too big, many orders of magnitude larger than it should be, or many orders of magnitude smaller than it should be. How did you know that? Well, you knew that because you've been working through those problems before, or you saw me work through one of those problems and you're like, I think that number should have been much different in size. But there's another way that you can do that, and that's by thinking about coming up with an approximation. An approximation is a guesstimate or an estimate for what a particular quantity should be. Sometimes those guesstimates are just gut feelings that you have, but sometimes you can actually kind of work it out and see what the answer should be, at least on an order of magnitude, a power of 10. So often you might want to make guesstimates to check again that your answer is correct or right or wrong, and that your physics question or your answer to a physics question is reasonable. And so I'm going to go through an example of one approximation right here. And approximations don't always have exact numbers. They're usually some estimate within some order of magnitude, within some power of 10. And so we're going to work through one here. And the one we're going to work through is approximate or estimate how many $1 bills stacked on top of each other could reach the moon. How many $1 bills to reach moon? That's all that I'm going to tell you. How many $1 bills could reach the moon? I'm not giving you any other information than that. So the first thing you want to do is ask yourself, what do you need to know in order to solve this problem? Well, we need to know the distance to the moon. That's something you might want to look up. The distance to the moon is about, this is an order of magnitude estimate, so I'm going to say it's about 400,000 kilometers, okay? And maybe we need to know the thickness of $1 bill. Okay, how thick is it? None of us are going to probably have a caliper or some small measurement device at home to really see how thin is a $1 bill. Maybe you could look it up online. Or you could think about, maybe I have 10 $1 bills in my billfold. What if I stacked those 10 together? How tall would they be? You can make an estimate. So I'm going to estimate that about 10 bills is approximately 1 millimeter thick. Okay, 1 millimeter is 10 to the minus 3 meters. Milli is 10 to the minus 3. So with that information, just that, we had to ask ourselves, what information do we need to know in order to solve this problem? Now with that information, we are going to figure out an order of magnitude estimate. How many $1 bills could we stack to reach the moon? So I'm going to start, there's a couple of different ways you could solve these problems, but I'm going to start with just one of the things that I know, which that the distance between the Earth and the moon is about 400,000 kilometers. Now, I know that, let's write this as sort of a conversion factor, kind of think about our conversion factors, that 10 bills has an equivalent height of 10 to the minus 3 meters, 1 millimeter. That's my conversion factor. So I'm going to start with my 400,000 kilometers, okay? And I know over here in my conversion factor that I've got 10 bills per 10 to the minus 3 meters. That's a millimeter. And so what I'm going to do is go ahead and convert my kilometers into meters. That'll make it easier for me when I put this conversion factor in here. So I know that 1 kilometer has 1,000 meters. That's 10 to the 3 meters, okay? And then, so my kilometers cancel here. I'm going to multiply it by my conversion factor for knowing the thickness of my 10 bills stacked together. So I'm going to multiply that by the fact that I know that 10 bills is 10 to the minus 3 meters thick. Remember, 1,000 is the same thing as 10 to the positive 3, okay? So I've got my meters canceling here and here. So I take my 400,000 times 10 to the 3 times 10, and then I divide it by 10 to the minus 3. And in the end, when I do that, I find that I have about 4 times 10 to the 12 bills to stack to get from the Earth to the moon, okay? That's 4 times 10 to the 12 $1 bills. And we learned that some powers of 10 have special names. 10 to the 12 has the name of tera. So if you have a storage device that's a terabyte, that's 10 to the 12 bytes, okay? So that's a lot of money. It's only slightly smaller than the current U.S. national debt.